Let me show you a situation every analyst has seen. You receive a dataset maybe from SAP or some other CRM. You open it and the table has 100 columns. You scroll to the right and you keep scrolling and scrolling and scrolling. And somewhere around column AF you start asking yourself, do I actually need any of this? Some columns contain only one value and others are completely blank. So technically those columns exist, but analytically they carry zero information. A column where every value is identical doesn't help us analyze anything. It doesn't help us group, filter, or explain variance. It's just data noise. Now imagine doing the cleanup manually. Scrolling, checking column by column, deleting them one by one. That works for 10 columns, not for 100. So the real analyst question becomes, can Power Query detect useless columns automatically? Let's think about the logic first. Before touching Power Query, we need a rule. When does a column contain no information? It's two cases. First case, the column is completely empty, and the second case, the column has only one unique value. A column is useful only if it contains more than one unique value. It's the entire idea behind this technique. Let's load the table first, just grabbing the data from Excel. If we want to test every column, we first need a list of column names. Power Query has a function for that. Table column names. This simply returns a list like this, customer, country, region. Now imagine looping through this list and asking the same question each time. How many unique values are inside the column? If the answer is 1, we throw the column away. If the answer is more than 1, we keep it. So we need a function that checks every column name. That function is listSelect. This means take the list of column names and keep only those that satisfy a certain condition. Now we need to define the condition. Now we simply count how many distinct values exist, and this gives us the number of unique values in that column. Now let's find the unique values. We extract only distinct values using listDistinct function. For each column name, we need the actual column values. That's what this function does. Table column. The underscore symbol simply means the current column name we are evaluating. So if Power Query is checking the country column, the function returns the values of that column. Now we can analyze it. After this step, we can apply the rule we defined earlier. If the list count equals 1, this column should be removed. This entire logic produces a list. We call it columns to remove. So after Power Query finishes checking every column, we end up with something like this. Now we simply tell Power Query, remove only those columns. Table remove columns, source, columns to remove. Pretty self-explanatory. And suddenly the dataset becomes much cleaner. No empty columns, no constant columns, just the data that actually matters. This approach lets you detect informative columns automatically. Instead of manually reviewing every column, we let the data decide which columns are worth keeping. But there is an important limitation here. This method checks every value in every column, which means Power Query has to scan the whole dataset multiple times. For medium-sized table, this works fine. But if you start working with millions of rows, this approach can become slow. So in large data environments, analysts often take a different approach. Instead of detecting useless columns inside Power Query, they define them at the source itself, inside the SQL query, inside the data warehouse, or inside the sub-extraction logic. The scenario where it shines the most is when you receive a brand new dataset and you don't know it yet.